Okay, if you haven't seen Alex before, buckle your seatbelts. It usually moves very fast. And here's Alex Powers.
Oh, thank you, Gary. I'm always a pretty interactive guy, so if you'd like to follow along, definitely do so. It is case sensitive, so that uppercase K, lowercase k will trick you out. Just find that. Just want to go ahead and kind of start here. So the funny thing with DAX that that's not it. Gary, do you mind if I start from the top again?
Okay, ready? Take two. All right.
So with DAX, you kind of have to. That's not it. I would say DAX kind of feels something like this. I'm just about to say it. DAX is big. DAX is scary. DAX is the mountain we must climb if we want to get to the top. Which is why I'm excited to take this journey with you today and welcome you to an introduction to DAX. For those who may not know me, my name is Alex Powers. I'm an MCSA in BI reporting, a MTA in Python, Office expert in Excel, Office specialist in Excel and Access, Microsoft's How We Excel contest winner. If you can't tell by now, I'm going long in the Microsoft technology stack. A bit of a millennial whisperer and a trainer. So if you have some talent in your office, you'd like to get them off their mobile phones and into these products and services, feel free to give me a call. It's a pretty straightforward sales pitch. And I usually don't like bringing politics in these types of sessions, but I felt the need to kind of say this now. I do enjoy pineapple on my pizza. So I will give you 3 seconds to go ahead and boo me if you'd like. 1, 2, 3, and we are moving on. Today's objectives. Objectives are pretty straightforward. So today, number 1, you have to be able to walk away and at least begin to start understanding what is DAX. In the conversations with the coworkers, our leadership, what is DAX? Number 2, if you're already in the trenches of DAX and you're screaming, why DAX, why? Let's go back to basics today. It's an introduction to DAX. Maybe connect a few of those missing dots. Get kind of lost along the way. And then number 3, most important of all, we need to have some fun. My boo guy, he didn't even say anything on the pizza gif. All right, so with setup, if you've not already done so, please download the file, follow along. And with that, I'm going to go ahead and open up DAX Studio here. So you can just go down to DAX Studio, and then we're also going to need to open up that Power BI file. So I'm going to open that up on my desktop. So I'll need both Power BI desktop and DAX Studio running at the same time.
Put your link back up there on the screen again.
Yeah. Let me know whenever everyone is downloaded that or is ready. You may want to be following along. Everyone good? Thumbs up? Awesome. So we have Power BI Desktop open. We hopefully have DAX Studio already open as well. PBI SSDT model. We can see our sales demo file from Power BI Desktop. If you want to go ahead and click on that, then we'll select Connect. Snap left, snap right. You can kind of see the similar experience here. So we have our calendar. We have our colors, customer transaction. You might not see colors in yours. Customers, employees, all the data, or I'm sorry, all the data tables. Oh, did everyone download DAX Studio from the SQL BI? I can do that real quick then. SQL BI, DAX Studio. If you just want to type in that in your browser, I think the link is pretty straightforward here. SQL BI, tools, DAX Studio. People need a moment to download that. All right. Call it, Gary.
I don't know how you did it up here, man. It's freezing. Like the air conditioner's going on over here or something. Thumbs up? Anyone? Good? Keep moving along. All right. Let's close out of DAX Studio here. So on our left-hand side here, I'm going to go and just go full screen to DAX Studio. This we're going to be playing today. Go ahead and turn on server timings up here at the top. And then also we'll just kind of take a quick look here in terms of navigation. In the bottom left-hand corner, we have metadata, which displays all of our tables. And then we also have the functions tab, which displays all of the functions that are currently available within DAX. Excellent. We're going to kind of jump back to here. So what is that? It's kind of just a simple query language. So SQL, SQL Server user group today. So I know we have a lot of code founders here in SQL. This will feel very familiar, maybe a little foreign if you're kind of from the Excel world. But we also need to think about what is our return values that are available within DAX. So we have our tables, we have our list. We also have kind of our scalar, our single values. So 3 different types that we can return within DAX. I'm going to jump into the window now. We're going to write a little bit of DAX here, if you don't mind. Actually, a lot of it, so get used to it here. We're going to start with this simple statement here. We're going to say evaluate, and then we can do tab to autocomplete. We're going to say customers, tab to autocomplete. Just run this. You can do the top left if you'd like, or F5 if you're a keyboard key kind of fan. If we go down here to the bottom of our tabs, there's output, there's results. So if we go to results, you can now see we return the results of the customer's table. So thinking about SQL, this is kind of like a select star from, right? So let's try maybe another thing that we kind of can borrow from the SQL world. So let's do evaluate customers again. Let's try an order by statement. Do a square bracket to identify our column, so that customer ID. Then what are some of the properties there of the order by? Yeah, so let's try ASC. Just go and highlight that, press run. Now have customer ID and ascending values. Maybe like a where statement, like our filtering of our tables. We're going to do an evaluate statement again. This time we're going to use the filter function. So this says returns a table that has been filtered. So we know we can send in a table, which is going to be our customers. And the value which we would like to filter based on. Let's do customers again. And we're going to do state provenance code. Zoom out a little bit here. There we go. Equal sign, and then with text, double quotes, good old Missouri. Close that out. Now we can run. Select star from, order by, select from where. This is SQL. So let's try another one here. Instead of selecting the entire table, let's maybe just select a single column here. So we're going to do evaluate the values function. Returns a one column table, so that is our list, or a table that contains the distinct unique values in a column. We're going to use the customers table once again. We're going to do this by customer name. And let's do an order by customer ID. Default property is ascending. Let's go ahead and run this. All right, well, we have an error. What's going on? Who said? Up here? Order by customer ID, customer name? No? Column customer ID cannot be found or may not be used in this expression. Well, I brought back a single list of customer names, so the whole thought process of customer ID no longer exists. Go ahead and do just an order by that customer name now. Sending. Let's try it run. Query started, query completed. There's my names. So we need to stop thinking about in terms of tables and start thinking about what are the elements which we are returning. So either that table, that list, or maybe just that scalar value. We're talking about querying our DAX. I did trick you guys on that one, so I just want to let you know. Let's try kind of just that scalar value now. So let's do an evaluate statement again. I'm going to do a open curly brace, and I'm going to do a count rows. From our table, customers, close parentheses, close curly. Let's go ahead and run that. Single value. Going. Let's try and evaluate though, because I don't really like the single value. It doesn't really tell me much. I'd rather know the row. Returns a single row table with a new column specified by the DAX expression. So I'm going to do an open parentheses, and what is the name of it? I just want to say customer cities. That'll be the name of my row and kind of the value of the header. I'm going to do a comment. I'm going to do a distinct count. So what is my column name? So I'm going to do the customers table based on the city. Close square, close parenthesis, one more. So we now have the header identified as customer city. So we can think of the select as kind of giving it our alias. Group by. SQL, right? Group by for aggregate kind of our expressions and values. So let's try a group by statement. We're going to do an evaluate here again. We're going to do a group by function. Creates a summary, the input table grouped by the specified columns. So we have our table, we have our group by column name, their second argument, our name, kind of our measure, and then the expression. So let's try this here. So our first argument that needs to be satisfied is the table name. Still sticking with this customers thing here, comma. So our columns, I'd like to note by customers square bracket state provenance code, comma, customers city, close square, total customers. That would be the name of our column header, comma, and then we're going to do a count X. Let me go back to the arguments here. So the table and then the expression. So I'm going to actually use a current group function, which is open and close parentheses, comma, and we're going to just pass in the value of 1. So every record is worth 1. What was that? Now I'd like to order by. Can I order by total customers? Yeah? It's in there? Yeah, I would agree.
What you're telling me.
Yeah, you're right. Total customers. So let's do by descending order. I want to know the largest to the smallest.
Can you explain the difference between count X and count?
I can, but that comes later. So you'll have to wait, sir.
All right. Sounds good.
You know, if you enjoyed pineapple pizza, that would.
You don't.
Yeah. So we created a column. It's now been exposed to our table. We can now perform other kind of order by, or we could even do a count of that. But I'm not a big fan of group by. I don't want to bring in a full table that customers if I don't need to. So let's try just like a summarized column. So how do I just select the 2 columns that I want? We're doing evaluate. And let's do a summarize columns. Create a summary table for the requested totals over a set of groups. So let's try this now. The groups that I started with was the customers, state, provenance code, comma, customers, city. And actually, that's me it. I don't want to do any actual aggregate just as of yet. So selecting 2 columns, summarize columns. We want to know that total customers now. So let's do another comma here, and we're going to do total customers. We do account rows. The table, which I'll pass back as customers. Awesome. Let's try this. Total customers. I've created a table now. I can also filter off tables, right? Let's go back to our filter function now. So we're going to wrap this in a filter. First argument is our table, which we've just now created. Our second argument here, comma. We're going to do total customers greater than 1. Out of here until you type. Total customers greater than 1. This is a querying language. Let's try this again. Maybe with join properties this time. Evaluate customers. What does this look like in SQL land? Select star. So let's try a join property this time. So we're going to do evaluate. We're going to do a calculated table, which evaluates a table expression in a context modified by filters. So I'm going to do my table, and then the context which I would like to filter by is customers with transactions. So now these are all of my customers who are in the customer transactions tables. So any customer that had a transaction. So this is now our join properties as well. If we were to look down here in our server timings, let me go ahead and again, it might not give us a preview on this. Oh, there we go. So in our server timing section, we can actually see the SQL that is being generated. Define a simple index on the customer ID from the sales customer transactions tables. Create a left outer join statement between customer transactions and sales customers. The next step, go through and identify all the columns in that table, because that's what we told it to bring back, where customer ID is in the index. It's defaulted to an inner. So that's why we're bringing back everything that is.
Yeah, how do you specify?
Oh, the column. So that is done through your relational model. So make sure this is sound before you kind of jump over to DAX Studio. Cool. And let's try the inverse. So who are the customers that didn't make transactions, right? So let's do an evaluate statement again. We're going to do a filter. So we know that we can kind of filter our tables now. So our where statement, customers. It is empty function. It's true if the specified table or table expression is empty. I'm actually going to have to reference the relationship of this one. So I'm going to say related table. Returns the related tables filtered so that it only includes the related rows. Off of customer transactions. Close parenthesis, close parenthesis, close parenthesis. Just kind of scale this back. Do a quick run. So these are all our customers that did not have transactions, so our is empty. Impressed. Talk me through, what are you guys thinking? How are you feeling? DAX is a querying language. What are your thoughts?
Very different approach to DAX than traditional.
Anyone else? I'm thinking. You said DAX is easy. It's okay. this one. Who else has run DAX? Big DAX studio. Oh.
Like you're my pineapple pizza guy. All right, so we're gonna kind of move on then. If you guys have any questions about the querying language, we're kind of seeing that it needs to bring back a table, list, or maybe just think about it in terms of the scalar value. Think about it as formula language, so data analysis expressions. When we think about that, we think about traditionally like, oh, DAX, I need to think about my tables. It's not true. It's all about columnar. I showed you when we broke apart that list, it no longer existed as a complete entity. I can now remove the pieces that I want. So let's kind of put this into practice then. So we're going to jump back into DAX Studio. Just kind of doing some aggregations now. Let's start out with the simple stuff. We're going to do just a row, kind of return back our single row with our alias. I'm going to call this total unit price, comma, sum function. An easy one from Excel land. Sales order lines, unit price, close parenthesis. Run this. What type of value am I going to get back? A table, a list, or a scalar? Single. Yeah. So scan my entire table, return the sum of the unit price just on that one column. So columnar. And you kind of thinking about here. Let's try another one. This time, let's do the average of the unit price. Someone help me out here? Faster than me. All right, unit price. Yep. Do the right way. Come on, there we go. Magnifier here too. Average unit price. Just a select, average, just an alias. That's all we're doing here. And let's do evaluate one more time. You're going to get really good at that statement. We're going to do a row. I'm going to do 75% of unit price. I'm going to use the percentile X. So it returns the kth exclusive percentile of values in a column. So about our columns now, sales order lines, unit price, period 75. Close parenthesis, close parenthesis. Single values. Also logical. How about that? Do a just curly brace here is empty. Previous function we've used customers. Curly. True or false? False. Negation. Can we negate our values? All right. I'm going to evaluate and do a curly again. Do a not statement. So not is empty. Customers. I already know that it's false from my previous return. What is it going to be this time? True. True. So we can also do negation if we really needed to on just these scalar values. Can we filter our results for aggregates? Maybe our table's going into them. So we've already written a query to go out and filter our table. Can we now aggregate over that filter table? Probably. So let's try this theory. I'm going to do the curly brace here. I'm going to do a calculate function. Evaluates an expression in a context modified by filters. We're going to do a count. Do orders. Square bracket, order ID, simple expressions here. And I'm going to pull from the customers table, and the customer ID is equal to 41. So kind of getting back to that calculate, I want to really kind of concentrate on that one. So we have our expression, and then we have our filter. So I'm telling it to go out to the customers table and filter it based on the customer ID of 841. And then, because it's columnar, I'm saying go out to the count of the order ID column. So let's try this now. 123. And let's see what the, let's kind of compare. So we're going to do accounts, orders, order ID, close square, close parenthesis, close curly, squiggly, wherever you end up in the debate. 7,350, 73,590. And down to just those results. Another. Evaluate. We're going to do a filter. So my arguments is our table. And then what is the filter expression? So in this one, I actually want to do add columns. It's a table with new columns specified by the DAX expressions. So I'm now going to add columns together. When I am going to do my calendar table, I'm going to create a column that says total unit price. Do a sum. Sales order lines, unit price. And close that out. Close that out. I'm going to create a filter based on my new column that I've created, total unit price that is greater than 0. I'll close that out. Press run. Yeah, I did. Well, on one we sold long number. Second, we sold the same number. Third. Is that right? Doesn't feel right to me either. Tell you're anxious for it. So right here, I told you it was columnar, right? I performed it over the entire column, and I brought that back. I didn't really tell it what to do, though, in terms of context. This is where we need to start thinking about filtering context. So by default in Power BI, it is defaulted to filter level. So I'm going to do a calculate around this, just kind of wrap it to force it into a filter context. I'm going to run this now.
Say all that one more time.
Yep. Let's talk about this in kind of a SQL language. So select from where date equals sum based on that. Select from where 2, where 3. Put in all these. So I'm doing it now based on a filtered context. That is correct. Well, Gary, I see the wheels turning. Talk with me.
I'm trying to walk it through myself.
So before, let me kind of get back here. The only instruction I sent to it was just go out and sum that column. I didn't tell it to filter. I didn't tell it to do anything really. But if I pass through a calculate function, which once again, it is defaulted in Power BI. So this is only really a DAX Studio thing that you need to worry about just whenever you're kind of creating these. But now I'm going to say calculate and go based on a filtered context. My context is now 1, 2, 3. Yeah. It's not dependent upon the filter only. Yeah, you can. So I mean, if you're talking about like an ampersand, that's where you can do multiple conditions. Or if you wanted to do an or statement, it would be two pipes. So that'd be your either and or you could have that on your filter. So right up here we have our filter, our comma, and then our filtered conditions.
Yeah, I think I read it.
Yep, so let's take a look then. Calculate, so expression, we have our filter as our second condition. You'd be able to kind of add additional filters there. So if you're talking about like just ampersand, so like two conditions.
Define a filter, so it defaults to whatever you have before it.
Yeah, so it'll be just a filtered context. Great questions. Calculate's a tricky one. I'll just say it out loud now. That one tricks people up here. So let's jump back into maybe one more here, kind of within that same vein. We're going to do evaluate. We're going to do filter. Kind of the same one. We're going to get in good practice here. So our table that we're going to send into it, and our filter expression afterwards. So our table that we're going to send in, we're going to create our own. So add columns, open parenthesis, and we're going to do total unit price. Get out of there, comma. So that's the name of our aliased column. We're going to wrap this around with a calculate, so that way we can say go into a filtered context. We'll do a sum based on the sales, order lines, square bracket, unit price, close square, close parenthesis, comma. Whew. Total quantity, comma. Calculate again, pass it into a filtered context, sum, sales, order lines, quantity. If I can type close parenthesis, comma. Actually, let's leave it as that. All right there. We're going to say anything where total unit price, because we've now created this column, it's greater than 0. Tally type, killing me, man. Close parenthesis. Spell something right. Oh, there we go. All right, so two different columns. We filtered it by the context. Unit price and quantity. Total cost, right? So our columnar structure, can we just multiply unit price times quantity and we're good? Is that how prices usually work? It's usually based on like maybe like a row type of context, like a row based. So let's kind of jump back to here. So I told you that it's a columnar structure, but that doesn't mean that we have to apply those rules all the time. So I would like to talk about the data analysis X expressions that you were alluding to earlier. So our count X, or average X, many more X's, max X. That is how we're able to change it from a columnar. So now I'm going to say for each row, the unit price times cost, the total cost. Apply that for each row, so an iterative process, and then apply your sum at the very end. So let's jump back into DAX Studio. Let's see what this looks like. We're going to add another column here. So we're going to do total cost. It's our alias. We're going to do a calculate. Just kind of put that into context. Now we're going to do a sum X expression. This is the sum of an expression evaluated for each row in a table. So the first argument is our table. So we're going to do sales, order lines, comma, sales order lines, column unit price, times sales order lines. I can zoom out too far. We're going to do quantity. Close that out, Let's take a look. Total cost. The zoom is killing me. Just slide this over here so you can look at that. Talk me through it. Sum x. Where's the sum? What is the x? No? Really? So up here we kind of did it on a filter context. Right here we're going to change it to a row base, right? We're going to switch our context. So not just think about columns anymore, start thinking about rows. So if you think about this in your kind of mind's eye, it goes through and it applies this for each row, and at the very end, it goes through and sums that new column. So think about kind of that virtual storage that's creating. That's what kind of is happening on the side there. Traditionally, people might do like a added custom column to their table. Why would I not want to do that? Why couldn't I just make this my own column and my own table? Just call it a day. I don't need these X functions. More space, more memory. So kind of the trade-off with that is too, though, is if you get to a point where it's billions and billions of rows, creating an iterative process to go through each row, that might not be advantageous too. So decide when it's good and when it's bad.
So if you did the exact same formula for that last one without the sum x, the number would be.
Oh yeah, let's do that. Let's take these. Add this. Columns. That.
Found that the are the most fully understood
Yeah.
in DAX tendency for people to either just use sum x or always try to use sum. So I see a lot of times where people use sum x like there's two rows.
Yeah.
Generally speaking, it's not a big problem, but you can get into scenarios where
Anyone else using the X iterators? Horror stories, positive ones, anything? Breath. Let's breathe. Air in, air out. What are you guys thinking? Through it. Noah. Right, DAX. All right. Variables are awesome. Anyone else? Or I think DAX. Gary, anything? The DAX trenches?
I've written DAX a lot. So this is a different angle.
Yeah. All right. Not a lot to talk about this group. You guys are deep in thought today. I like that.
So let's move on then. Let's maybe consider like some time intelligence to our tables. Jumping back to DAX Studio. Just a word to the wise, I did have to print all these out because there was no way I was going to remember 160 lines of DAX for today. So, if I would have had one more day. All right, so we're going to start out with just our simple calendar table once again here. So let's do evaluate. I always feel like good practice is just constantly redoing things which we've created. So we're going to start out with a filter table, filter expression. So let's create our table that we're going to pass through that first argument. So our add columns returns a table with new columns specified by the DAX expressions. We're going to use just our calendar table here, which is just a single column. So it's just a list. That's why I don't have to specify kind of anything special there. We're going to do total quantity again. Sum, sales, order lines, quantity. Is that right? Calculate? Why? Specify the context, right? It's just something unique to DAX Studio. We're going to do a comma here. Do total unit price, comma, calculate. Let's do some sales order lines, unit price, quotation, quotation, total cost, calculate. What function? Max. Why? So we want to do a row-based iterator. So sales order lines we're going to do based on the columns quantity, lines, unit price, close parenthesis, close parenthesis. Awesome. Let's try quantity SPLW. So let's do a last week. Start over with our calculate. The sum here of total quantity. So sales order lines, quantity. And because I'm using a calculate, I can then use my second argument, which is my filter. So the filter I'm now going to do is I'm going to do a date add. Moves the given set of dates by a specified interval. Well, that's interesting. I'm going to pass in my calendar bracket. I'm going to use date because this one just does require me specifying the single list. I'm going to say -7, so same period last year, and the interval I'm going to select is day. Talk me through that. Yeah, let's do it. Let's think about calculate in our filter. So date add 1/8 minus 7. So thinking about our tables that we were talking about earlier, what are our return values? Table, list, or single value? 1/8 through 1/1. I'm just saying bring back this list of dates between the 8th and the 1st. Use that as my where condition, my filter context.
If you wanted to add another column that was same period, same day last period, you just want to look at last week.
Yeah.
It's relatively the same thing where you're just looking at during the 8th to the 1st.
Yeah. So just -7. So that's all 8 minus. And that's where we end up from the 8th all the way to the 1st. So that'll be what is returned back on that row.
We can kind of, if you'd like, let's go and close this out then. Maybe we're at like a good 25% point on this one. I'm going to pass through any filters here. Too many arguments. What's he yelling at me about? Keep this filter since I didn't specify anything. Oh, that's interesting. So filter, comma, let's do based on our total quantity, because we now created that column, greater than 0. There we go.
Well, why didn't it work with filter?
Because I didn't specify anything. Just struggling on that second argument because I didn't specify.
That goes all the way back to 13 million.
Let's see here. On the 8th, 5,187 back on the 1st, 5,059. Up 7 days, -7. Same period last week.
2 weeks ago, -14, -21, whatever kind of interval you'd like to specify. I think we can do better. Let's keep going. So quantity, same period last week. I'm gonna do a comma. Let's do a quantity SPLY, same period last year. Specify our kind of context here. Total quantity. Some sales order lines quantity. I think I've written it about 10 times here. Noah, talk me through these variables even. Variables and measures. Can I just reuse this measure across my DAX expression? I keep writing some quantity over and over and over again. Good catch. Let's go above this evaluate statement. We're now going to define a measure. I'm going to store this measure. Let me go back here. That's total quantity. Writing it several times now. And let's go ahead and try this now. I'm going to actually delete this quantity right here. I'm going to use the measure total quantity.
In the measure, you didn't define calculate. And calculate your filter set columns.
Using a measure will automatically put a calculate here. You don't see that. That's where I was talking about Power BI desktop, that whole calculate started going in the background. So every measure you kind of reference is run by calculate.
And the input was reached. Ah, good catch. So we're going to use a total YTD, so total year-to-date function, evaluates the specified expression over the interval, which begins on the first day of the year and ends with the last. So we're going to use our total quantity measure since we've already specified that. Close that out. We're going to say just our expression, our dates, so we can reference our calendar, and our date column, square bracket, close parenthesis there, and hopefully we're getting close. Quick look here, just to make sure we can use this. Too few arguments to pass to total YTD. Oh, there we go. Total quantity. So now let's remove it from some of these other ones. So I don't really need to use it here. I can just reference my total quantity measure that I've created. Total YTD. Once again, just reusing measures. The way I would approach DAX is always think about your problem in the smallest form. So just a simple sum, create that as its own measure. Start building it up dynamically from there. Other filters or the kind of adjustments, date add or a rolling time period here with our total YTD. So quantity, and actually let me change that to YTD. There we go. do quantity SPLY since I jumped ahead here a little bit. So we're going to do a calculate total quantity. We're using that measure, comma, one of my favorite functions. It's so easy. Same period last year. Nothing fancy. Returns a set of dates in the current selection from the previous year. I already know my dates are stored in my calendar table. And the date column, closed, closed. Good. Where was I off here? Query results. Same period last year. If I was kind of go through, I could see here, adjusted 1 year back on January 20th, 2017. So my previous year would have been 2016 on that day, 9,298. Let's try it rolling. So creating a list of dates based on where I'm at in the context of my filter. Kind of creating it dynamically, 116 turns into 17 as we continue to go. So 24th all the way through the beginning of the day, or our min, or our earliest value here. So we're going to do quantity rolling, comma, calculate. Total quantity, kind of reuse our measures here. My filter, so my second argument, I want to say the dates between. Return the dates between two given dates. What type of value is that returning? Is that a table, a scalar, or is that a list? List? Yeah, it's a list. So we're going to see our calendar is our table to reference for the date, or bracket, date. Our min, so our earliest value, calendar date, parenthesis, comma, and then I want to specify the current date in which I'm at, so the calendar date. Close, close, quantity rolling. $5059. 6240. 11299. 7518. Dates between my earliest date. So I'm going to continue to create a dynamic list. 1 1. 2 that includes 1 2 1 1. 3 2 1. 3 2 1. Dynamically creating that list based upon current context. Filtered context. Talk me through it. See some light bulbs. What's going on? Anyone? It could just be missing. That there's just no results for that time period.
If you wanted the rolling count to reset every week, every month, every year, is that something?
Technically, you'd want to just use like the calendar table, right? It's like a week number would be your condition. Then you say filter based on the condition. I wouldn't worry about hard coding or anything.
Month-to-date function.
Yep. Keep going. All right. Now start out with adding a new column. So we've created a table. I want to start using these tables to maybe find out like a difference between the two columns. So at the very beginning here, right after evaluate, I'm going to do added columns. We've already got my table that we've created. So total quantity is anything above 0, pass through. And then we're now going to create, what is the difference between SPLWs? So our same period last week's. And I notice here, I don't always have a value. So maybe like an if condition. So we can evaluate saying if something is not available. So if logical test is blank, checks whether value, so our scalar, is blank and returns true or false. So if quantity, SPLW, blank, what is our condition? We just want to return back a blank, returns a blank value. So open parenthesis, close parenthesis. And then now we want to do total quantity divided by quantity SPLW minus 1. Just to make sure I follow PEMDAS. What is this and? It keeps trying to type in. Get out of there. And then we're going to close that out. Difference, same period last week.
2 add columns, filter. Add columns, we created this table. Next filter, we filtered that table. Any condition is greater than 0. Create another add columns based on that table. We said difference, same period last week, where if this condition is not blank, perform total quantity divided by quantity, same period last week. Find out the difference. Table that we filtered into a table, we then added to our table.
If is blank is just working for divide by 0 error.
Yeah. I want to go into something deeper, but yeah.
Keep going. All right, so we've got a table and a table and a table. Let's try now filtering based on a top n. So our n value, our second argument is our table, which we know we've already created. So let's say that our top 10 values based on this table we've now created. And then the argument here is going to be difference, SPLW, so that column we've now created. And I would specify the order, which is going to just be a descending order.
Equal. Like from top table.
Let's try one more. So now we'd kind of talk about variables. So we can store maybe tables in a variable or a list or a single value such as a true or false. This one I actually want to store a table. So I'm going to call it June only equals a filter on my table or filter expression. Table is just a kind of word here I can still pass through a single valued list. So I'm going to do a values based on a calendar, a date, comma, I'm going to say month, calendar, dates equals 6. So June only dates. Instead of pointing to this calendar, I'm now going to point to my June only table. Oh, what happened here? Oh, my return statement. Query started. June only. There we go. I was like, why are there February in there?
Top 10. June only. Variables store a static representation of your data. They're not dynamic.
Kind of keep that in mind. So when was a good kind of use case for a variable?
Like logical. Good use case for variable. There's a lot of filtering or some sort of weird context that you're creating up top, using multiple times.
Reason to keep going back to the well and recreating things. Pencils down.
Great job. You're done. Everyone's feelings. Eric, talk to me. Does anyone think that DAX is a querying language, or are you all under the impression that it's just a formula-only language? I know the branding's telling me that's a formula.
It's always been equated like Excel.
Yeah. It's kind of like this weird hybrid of both like a query that we need to think about, and also what is the aggregate. We like to kind of that table here. Our objective. What is DAX? DAX is the native formula and querying language. Microsoft Power Pivot for Excel, Power BI Desktop, and SQL Server Analysis Services. Learn one skill, applies it to 3 different programs. Awesome. DAX includes some of the functions that are used in Excel formulas, you kind of alluded to. But I think here, kind of most importantly, is Microsoft statement. More simply, DAX helps you create new information from data already in your model. We're kind of creating those dynamic attributes, maybe going back in time, forward, list. I would not feel right leaving today without talking to you at least about the VertiPack engine, kind of what's going on underneath. VertiPack engine exists as both a dictionary encoding, column encoding. So we talk about our columnar databases. So what does this actually kind of look like in theory? So we have our table, we have our entities, so we have our attributes, is our color and our value. What it does is it goes through and it creates a dictionary based on the unique items in our list. Red, blue, green, yellow, purple, orange. It finds the cardinality. What is the unique cardinality of this table? It then goes through and indexes those in our column position. So red is 0, blue is 1, green is 2, 2, 3, 3, 0, 1, 4, 5, 0. So things don't exist together, they exist on their own. The same little value. So 0 is 10, 1 is 15, 2 and 2, 3 and 3. Then the VertiPack engine goes through and it scans based on what is this ID number in a process that is called run length encoding. I don't want to get through that. That'll be another session if you guys come back. Basically what it looks through, what is the cardinality of the elements. So if we were to add another color or descriptor here, that would change the cardinality, right? So if it was color and it was size, we'd have to think, what is the uniqueness of our table? Our value, which goes through and it filters. So select from red, sum it where? 36, 29, 38. The VertiPack engine.
I want to kind of show this in practice here now. Back to Power BI. So we have our colors. If I was to kind of look through this table here. Red, blue, green, green, yellow, yellow, red, blue. All right, so we know that there are duplicates. I'm now going to drop the colors onto my canvas here. Blue, green, orange, purple, red, yellow. Did it bring duplicates? Quite unique value, right? Drop in values now. Let's make sure that that's a sum. Goes through based on those positions. Was in return. Select from where? Green. I'm going to let you in on a little secret about DAX. There's only 2 parts to it. First one is select distinct. Select from where? That's DAX. Select distinct, select where. That's not from me, that's from the Italians. They told me that to say that. So. Done. Real time. Remarks. I'm gonna let you guys go here. I know we did a lot today. At some point, I probably lost you. It is entirely by design. I need to make sure that this is making sense for you. If you're coming from a SQL background, thinking in terms of like tables, list structures. If you're coming from more of an Excel background, think about how can I
look past just the simple sum or average formulas and start thinking about injecting data structures, which kind of brings me back to it's not about the cell. So that is my business. It's really about the creative mind and kind of the process going into solving your solutions and then kind of thinking what is the outcome you'd like to achieve. With that, I will leave it up to you for any questions, suggestions, or if you downright just think that I'm crazy, speak now or forever write about me online. Anyone? Awesome.
I feel 20% better with DAX.
Awesome. So I can give a personal story. Like, I read the definitive guide to DAX probably like 2 years ago. And I was like, man, this is great. And I talked to people online. Like, I've read it on my 4th time now. I was like, why did they have to read it 4 times? I don't get it. So probably like the next 18 months, we're really just like a struggle and a fight to kind of really get back to basics. Like, what does a simple table look like? What does a list look like? Really kind of approaching it in a different way, which I think Gary's kind of alluded to. It takes a while to kind of wrap your head around it. You know, this is the mountain of Power BI. Like, this is the mountain we must climb. That's just an honest statement. The only resource that I will highly recommend is SQL BI. No one better. If you want to go deep into the well, these are the guys to go to. They do have a free course for Introduction to DAX. It's nothing like mine, but I will tell you for a free course, there's probably like 90 functions, and it is extremely good for free. I don't know why they're giving it away for free, but I'll just keep saying free. So it's kind of embedded.
They run patterns, so I can go to DAX patterns.
Yeah.
All the time. It's up there on the toolbar, but it's very informative.
Yeah. A couple really good books, DAX patterns, a lot of other patterns they've already written. You just simply replace theirs with your column names and your off the races kind of solutions. Kind of Gary mentioned this earlier. St. Louis Power BI user group. We love talking about Power BI. We love talking about Excel. We're free to hang out. You're talking to myself and Matt in the back there. Trying to grow this thing. Luckily, with Gary's help, kind of really injected some life in here, getting us a little bit more regular. So we appreciate that. And also, if you'd like to find me online, if you have your mobile phone and your LinkedIn app, if I've not already hunted you down online and added you, at the very bottom left here, you can do My Network. And at the very top, you can do Find Nearby. And if you have the mobile application open now, we'll go ahead and show that we're both here in the room where you can connect with others. That way we can kind of take it offline if you'd like to continue nerding out. With that, go forth. Awesome. Thank you, everyone.
Thank you, Alex.